Today we are going to learn about scaling datasets using Scale and Merge in the Phenix GUI. The purpose of Phenix Scale and Merge is to combine data from multiple crystals. Let's see how Scale and Merge works. The key features of Scale and Merge are local scaling and automatic assessment of intercrystal variation. Let's look at local scaling. We use the intensities from one crystal as a reference and scale the intensities of another crystal to that reference. We use a scale factor that is local so that it can take account of effects such as absorption that vary across the diffraction pattern. Let's get the scale factor for a particular reflection. We take the average intensity for all the reflections in a sphere surrounding the reflection in the reference crystal and compare it with the average intensity for all the same reflections in the crystal we want to scale. We leave out the reflection we are going to scale so we don't bias the result. This gives us a scale factor for this reflection, and we can multiply our measured value by the scale factor to give a scaled intensity. The process is repeated for each other reflection to give a scaled dataset. Now let's look at merging data obtained from several crystals. We want the anomalous data corresponding to an ideal crystal. We will use amplitudes f instead of intensities I, as that is what Scale and Merge uses. What we have is data measured from several real crystals. To optimally combine these data, we need to keep in mind that these crystals are actually different and consider the crystal-to-crystal variation. Let's imagine how the data we measured are related to the F plus and F minus for an ideal crystal. If we measured data from an ideal crystal, the observed F plus, F obs, would be the ideal F plus with some error in measurement, sigma obs. Now if we measure data from a real crystal, the observed F plus will be the ideal F plus with errors in measurement, sigma obs, and also variation between this crystal and the ideal one, sigma crystal A. Now when combining observations of a particular reflection, we can weight each observation based on the error in measurement and the intercrystal variation. The weights are 1 over the squares of the sigmas, so big sigmas mean small weights. We can estimate the intercrystal variation for each crystal from the differences between the data for each crystal and the average of all crystals. The data from crystals that are most similar to the average are weighted more strongly, and the data from crystals that are more different are weighted less. Here is the procedure for scaling and merging. The data are first locally scaled to the average of all datasets. Then the observations from each crystal are combined, taking both uncertainties in measurement and intercrystal variation into account to produce scaled anomalous data. Note that you can use Scale and Merge with native data without anomalous differences as well. Let's apply Scale and Merge to some data from the Phenix tutorials. We are going to use some very weak data from an NS1 protein. We will scale just 4 datasets to see how it works. In the main Phenix GUI, click on New Project and then Set up Tutorial Data. In the pull-down menu under Other, select the NS1 Low-Resolution SAD Data Tutorial. Choose a suitable place to put the files and hit OK. Let's run Scale and Merge. Under Reflection Tools, select Scale and Merge. Let's enter a title. Let's find the data in the tutorial directory. Under Anomalous Data File, hit Browse and pick all 4 data files one by one, using the plus sign to add additional files. You can also make a directory and put all your files in it and just specify that directory. The data for Scale and Merge should be unmerged original index data. That means that the data files have individual observations kept separate and record the original HKL indices of the data. If we scroll down, notice that the unit cell box is empty. This means that the data files we used, which are ScalePack unmerged format, do not specify the unit cell. Let's put it in now. Let's look at some of the parameters that are set for us by default. Require F plus and F minus means only include an observation of F plus if the corresponding F- is present in the same dataset. This helps reduce systematic errors by always pairing reflections measured from the same crystal. Scrolling up, if we click on the Scaling button, the Make Anisotropy Uniform parameter is set to true so that anisotropy for each data file will be adjusted to match the average. Under Merging, notice that we have chosen to include the interdataset variance. We have also chosen to optimize anomalous differences. If we were using non-anomalous data, we might turn that off. We're ready to go. Hit Run, and as Scale and Merge starts, a new Scale and Merge run will appear. The Log Status tab will show the log file. Let's look at some parts of this log file. First, each dataset is scaled with local scaling. Notice that the anisotropy in the data files is examined so that it can be made uniform. The data files are first scaled using just an overall scale factor to put them on similar scales. Then the data are scaled using just the original sigmas without interdataset variation. The interdataset variation is estimated by comparing each dataset to the average and accounting for measurement errors. And the data are scaled again, including interdataset variation. Finally, the half-dataset anomalous correlation is estimated by splitting the datasets into two groups and comparing the anomalous differences between groups. The summary page shows the half-dataset anomalous correlations. For these NS1 crystals using just 4 datasets, it is pretty poor even at low resolution. A value of 0.3 in a resolution range is usable, but you would hope for something above 0.5 in at least your lower resolution shells. For these NS1 crystals, it took not 4 but 27 crystals to yield a useful set of merged data. Good luck with using Scale and Merge on your data. If you have questions or feedback, you are welcome to contact us at help@phenixonline.org or tutorials@phenixonline.org.